Hi guys, and welcome to this, our 27th and final lesson in the topic of Leaving Cert Statistics. And so in lesson 26, I spent a bit of time talking about what a p-value is and how you calculate one. So we spent a little bit of time talking about that in the previous lesson. In this lesson, I'm going to show you how we can use p-values to finish a hypothesis test. This is kind of bringing together everything we've looked at in the last couple of lessons about doing hypothesis tests when we're dealing with numerical data, when we're working with means. All right? And this begins in your notes on page 314. So if you look at the question on page 314, we just have a look at this kind of three questions we're just having a look at just to kind of tie this up. And the whole key point with this, remember, is that when you're dealing with numerical data, and the question involves means, when I write down my null and alternative hypotheses as I would do for any hypothesis, I then have to do a calculation on which to base my conclusion. And for numerical data, I've got three options for the calculation I choose to do. I can find the 95% confidence interval and check if mu is inside that or not. I can find the Z statistic, or the one sample Z test statistic, or whatever you want to call it, and check if that number lies between plus and minus 1.96. And now, based on what we did in the previous lesson, I can find the p-value and check if it's above or below 0.05. The most important thing to realize here is that these are just three different versions of the same calculation. It doesn't matter which one I do because they all produce the same result. I need to know how to do all three, but it's up to me. When I'm doing a hypothesis, I can choose my favorite when I'm working with numerical data. When I'm doing hypothesis for proportions, I can't find the test statistic or the p-value because I don't have the tools for doing that in my formula booklet. So when I'm working with proportions, the only calculation I can do in a hypothesis test is the 95% confidence interval, but for means, I've got a few more options, right? So if you look at the question 27.1 there, it says the 1972 movie The Godfather is considered to be one of the best movies ever made. An extensive 2010 survey of movie critics awarded The Godfather a mean score of 8.81 out of 10. In 2020, 583 movie critics were surveyed, and the movie received a mean score of 8.74 with a standard deviation of 1.28. It says to find a p-value, and then in part 2, we're asked to hence or otherwise conduct a hypothesis test at the 5% level of significance to test the claim that The Godfather's popularity among critics had fallen between 2010 and 2020. State your null hypothesis, alternative hypothesis in your conclusion. So again, it's a hypothesis test question. So we're in autopilot here, are we not, based on the previous couple of lessons? Okay, so I'm just going to pull the data out of my text this way. There's my little sketch. So step one, where's my sample group? How many of them are there? Well, you can see there in the second paragraph, in 2010, 583 movie critics. So N is 583. Okay, step two, pick your symbols. Are we working with proportions or means here? Is it P and P hat or mu and X bar? Or what question were the critics asked here? What score out of 10 would you give The Godfather? So it's numerical data, so the symbols here are going to be mu and X bar, right? Step three, identify the results from your sample group. So what was the result from our sample group? In 2020, 583 movie critics were surveyed, and the mean score was 8.74. And the standard deviation, which remember sigma is 1.28. Right? And then the final step, step four, because we're doing a hypothesis test, there should now be a number that goes up here for me to compare my results to. There should be a number somewhere in the text I haven't used yet, and there is, you can see in the second line there, the 8.81. And now I'm done with the text. Okay, so I'm hoping at this stage here we're getting a feel for that. That's how I pull the information I need out of a piece of text involving a hypothesis test. So to find the p-value, remember we did this in the previous lesson, the two steps in finding a p-value. First of all, I grab my formula from the top of page 35, this formula here, x bar minus mu divided by sigma over root n, and I pop in the values to find the z statistic, right? So I put the numbers in, so it's x bar minus mu, it's 8.74, and minus 8.81 over sigma, which is 1.28, divided by the square root of 583. Okay? And that comes out at minus 1.32. Okay, so that comes out as minus 1.32. Right, so minus 1.32, so what do we do now with a z value? We now look it up. Okay, so we now go to the formula booklet and we look it up. So if I go to my formula booklet as usual with any other z value, I'm going to look up 1.32. So find the number 1.3 out in the left hand. So there you go, 1.3 out in the left hand column there, 1.3. All right, and then find the second decimal with a 2 across the top. So 1.32 up there like that. All right, and that's the value we're looking for, 9066. Right. So if you remember, Now, once I found that Z value, if I go to my formula booklet on page 36, 37, this guy here, and put that number minus 1.32, so minus 1.32 is in here, all right? And then plus 1.32 is in there. Put the positive and negative versions of that number on this diagram here. And then this bit here and this bit here are my p-value. So adding those two together gives me my p-value. So if I look up 1.32, as we had a moment ago, I end up getting 0.9066. So when I look up the number 1.32 in my formula, I get 0.9066. Now, does that match the shaded area here? Nope. That shaded area is less than half. That number is bigger than half. So this bit here is 1 minus 0.9066, which comes out as 0.0934, right? And because the two sides of this curve are mirror images of one another, and these two numbers match, as they always will, this is 0.0934 as well. So your p-value is just those two added together. So it's just 2 times 0.0934, and that's 0.1868. So that's your answer to part 1. That's your p-value. Right. So part 2 then says it wants me to conduct a hypothesis test to check if the scores given by critics to the Godfather it changes. So remember, when I'm doing my hypothesis test now, there's my null hypothesis up there. Okay, so I write down my null hypothesis. So H naught is that mu equals 8.81. Okay, there's no units here. It's just a score out of 10 given by critics for a particular movie in a particular movie review. And then HA is that mu is not 8.81. Right? So now doing my hypothesis, remember I've got 3 choices. I've got 3 calculations I can do. I've 2 of them done already. So I found the Z statistic already. It's minus 1.32. I found the p-value. It's 0.1868. Remember, I could, if I want to, find the 95% confidence interval. So it doesn't make any difference. I've done my calculation here. So I'm going to use the p-value because I found it already. So the p-value here is 0.1868. That's bigger than 0.05. So we're comparing this, as we mentioned in the previous lesson, to 0.05. Okay, remember, because we're doing the test at the 5% level of significance, and 5% as a decimal is 0.05. Okay, the key thing to realize when you're doing a hypothesis test here, that if your p-value is above 0.05, you fail to reject HO. If it's below 0.05, you reject HO. Okay? So just remember, if P is below, HO must go. Okay? So if P is below, HO must go. It's rejected. Okay, so that's the idea here. So you can see in this case here, 0.1868 is above 0.05, as we mentioned there. So because of that, we fail to reject HO. Now, just be clear in your own head, wouldn't we have got the very same result if we did either of the other 2 calculations? Look at your Z value. And remember your Z value, Z equal to minus 1.32. That's inside the range. And minus 1.96 to plus 1.96. So we'd be failing to reject there. If you did go to the bother of finding the 95% confidence interval, so if I use those numbers to find the 95% confidence interval, the interval I get there, it's 8.64 to 8.84. And notice the 8.81 is inside that interval. So they're just 3 versions of the same calculation. They'll always give you the same result, right? So 8.81 is inside the 95% confidence interval. Therefore, the Z value of minus 1.32 is inside the range plus or minus 1.96. Therefore, the p-value is above 0.05. There are 3 versions of the same calculation. They will all lead to the same conclusion. We fail to reject H0. Okay? And what does it mean if you fail to reject H0? Remember, H0 is the assumption there's no difference. If you fail to reject that, you're sticking with the idea there's no difference. So that means the conclusion here is that there's no difference. So what does that mean in the context of this question here? There's no difference between the scores awarded by the critics of The Godfather in 2010 compared to now. So what's the claim we were testing, that the score had fallen? Nope, doesn't look likely. So our conclusion is there's no evidence the claim is true. or there's no evidence to claim that the score has changed or anything along those lines. And that gets across the idea that your results would suggest there doesn't seem to be any real difference between the scores awarded in 2020 compared to those in 2010. That's all the examiner's looking for. That there doesn't seem to be any evidence for that at all. Okay? So that's just the final piece of the puzzle. So it might be worth kind of pausing the video there and just trying question 2 on page 316. So, question 2. It says, an online discussion forum claims that under 30s spend a mean time of 32 minutes on Instagram every day. To test this claim, a stratified sample of 40 under 30s was taken. For this sample group, the mean time spent daily on Instagram was 30 minutes, with a standard deviation of 6 minutes. So part 1, we will explain what's meant by a stratified sample. Part 2, construct a 95% confidence interval for the mean time spent by under 30s on Instagram per day for the entire population. Number 3, then hence test the forum's claim at the 5% level of significance, including our hypotheses. Number 4, comment the difficulty of drawing any meaningful conclusions based on the results obtained from the sample group. And then 5, find the p-value and say what it is. Okay, so again, it's a hypothesis test question here, so I'll pull the data. So part 1 just wants me to explain what a stratified sample is. So what you only want to get across there in a stratified sample, we covered the sampling methods in a previous lesson. A stratified sample is when we divide the entire population up into groups or strata based on some criterion. So you might divide them up based on gender. You might, in this case, you'll probably divide them up based on ages. Okay, so you divide the sample up based on their ages, and then you randomly select groups from within each stratum. Okay, so you divide the entire population up into groups based on some criterion. In this case, probably ages, because we're talking about under 30s. All right, and you randomly select from each stratum. And remember, it's worth pointing out that the proportion of your sample group from each stratum should reflect their distribution in the main population. So, for example, if 1/3 of the entire population are under 30, 1/3 of your sample group should be chosen from the under 30 stratum as well. Okay, so the key things to get across there is the idea that you're breaking the population up into strata based on some criterion. You're randomly selecting from each of those strata, and the proportion of people chosen from each stratum should represent their distribution of the population as a whole. Get those 3 ideas across. That's what we mean by a stratified sample. Okay, so to move on to the kind of the calculation-based data then, just autopilot here. So step 1, where's my sample group? There they are in the second line. To test this claim, a stratified sample of 40 of them, so n is equal to 40. Step 2, choose your symbols. Is it p and p hat or mu and x bar? Well, what question do we ask them? How long do you spend on Instagram every day? It's numerical data, so it's mu and x bar. Step 3, grab the results from your sample group. Where are we? And from our sample group, the mean time was 30 minutes. And the standard deviation sigma was 6. And then step 4, what were the results? What's the number I haven't used yet to go up here to compare my sample group to? Is there a number I haven't used yet? Yep, in the very first line, we've got the mu is equal to 32. So now I'm done with my text. I'm hoping that's becoming clearer now. We've done that for a couple of lessons at this stage. So part 2 then, do your 95% confidence interval. So remember, your 95% confidence interval is x bar plus or minus 1.96 times sigma over root n. Okay, so it's 30 plus or minus 1.96 times 6 over the square root of 40. And if I do this calculation with a minus sign here, I get 28.1. Okay, and remember it's in minutes. I do the calculation with a minus sign here, I get 31.9 minutes. And my best guess is that the true value for mu is inside those two. Okay, there's your answer to part 1. Or sorry, part 2. And you see now when we do a hypothesis test, that number there is bigger than this. It's outside our interval. Okay, that's kind of the conclusion we're going to draw now in a moment. So in part 3 now it says to do your hypothesis test. Okay, so hence test the forum's claim at the 5% level of significance. So because this is the only calculation I've done so far, I'll just use that one to do my hypothesis test. Okay, I don't need to kind of go and do anything else. So in part 2, if I write down my 2 hypotheses, remember there's my null hypothesis as always. So H0 is that mu is 32, and I'll put the units in there. And then HA is that it's not. Do your calculation. Done already. And now use your calculation to draw your conclusion. So again, this number here is outside the interval, so we'll mention that. So mu equal to 32 minutes is outside the 95% confidence interval. And remember, if it's outside your confidence interval, therefore you reject H0. Okay? So we reject H0. Now, what does that mean then? What's your conclusion? So if you reject H0, it means, remember, that your H0 is the idea there's no difference. You reject that, your conclusion is that there is a difference. So what does that mean in this case here, that there is a difference? There's a difference between what the forum said people were spending their time on Instagram and what's actually happening. So it looks like the forum's claim might be garbage. Okay, so we'll write that's our conclusion. There's evidence that the claim is false, so there's no evidence the claim is true, whatever way you want to phrase that. There's no evidence the claim made by the forum is true, or there's evidence that the time spent by people on Instagram is not the 32 minutes claimed by the forum. And then that gets across the idea that that claim there, the one made by the forum, looks dubious to us now. That's your hypothesis test, okay? So part 4 then says, comment on the difficulty in drawing any meaningful conclusions based on the results obtained from this sample group. So if we can't say, look, we can't turn around and say, well, look, that's very clearly garbage. The forum made that up. Why might there be some issue here with the results from our sample group? You can maybe see what he's pushing towards there. It's way too small. Okay, so we can't go draw any meaningful conclusions here from our sample group because the sample group is way too small. Okay, we only asked 40 people. We'd want a much bigger sample size to draw any kind of meaningful conclusions. And then part 5 is to find the p-value, do that p-value calculation. Okay, so the p-value calculation, the first thing I do is I go to page 35 and find my Z formula. So my Z formula, it's x bar minus mu divided by sigma over root n. And x bar is 30 minus 32 all over sigma, which is 6, over the square root of 40. And that gives me an answer of minus 2.11. Is that surprising? Not in the least. That number is not between plus and minus 1.96. Why not? Because 32 is not inside our 95% confidence interval. Remember, there's 2 versions of the same calculation. That makes perfect sense in my head. So I could say, look, because that number is not between plus and minus 1.96, we'll reject H0. And there's evidence the claim is not true. Okay? But we'll go ahead now, we'll look this up in your formula booklet. So remember, what that means now is if the Z value is minus 2.11, there's my curve from page 36, 37. There's 0 there. And minus 2.11 is down here. We'll put the plus version in as well. And those 2 shaded bits there make up my p-value. So let's look up 2.11 in the tables. And where's 2.11? Well, there's 2.1 there. And there's the 1 there. So 2.11 is this guy. So it's 0.9826 in my formula booklet. Okay? So if I look that up, I get, so look at that number up, I get 0.9826. Okay? Now, is that shaded area 0.9826? Nope, it's too small. That shaded area is less than half. That number is very conspicuously bigger than half. So it's 1 minus 0.9826, which comes out at 0.0174. Okay? So that bit there is 0.0174. And because the curve is symmetrical, so is this. So your p-value is just those 2 added together, or in other words, it's just that number doubled. Okay, so it's 2 times 0.0174, which is 0.0348. And again, not surprising, that's below 0.05. So we'd be rejecting H0. So see the way the 3 calculations, because we've done all 3 of them in that question there, they all produce the same result. Okay, 32 is outside our 95% confidence interval. Therefore, our Z value is outside the range minus 1.96 to plus 1.96. Therefore, our p-value is below 0.05. Those 3 things we'd use to be deciding that we'd be rejecting H0. Okay, they'll all produce the same result. And we're asked to comment on what that p-value means. And what that means is the probability. Okay, so we mentioned it's a probability of a different sample. So if you went to the population and grabbed a different sample of 40 people, okay, having a mean result, or just a mean, further away from 32. okay, from the 32 that was quoted on the forum, than this group. This group's mean is 30, is 0.0348. So there's a very, very small likelihood we could find a sample group more unusual than this one if that mu equal to 32 was true. That's why we kind of say that mu equal to 32 might not be accurate. So probability, different sample group, a more extreme result, further away from the one that was quoted for the population. Okay, so the final question then is the one on page 319. You maybe pause the video and try that one, just make sure you've got it. So, it says, the mean lifetime of light bulbs produced by a company has in the past been 1,500 hours. A sample of 100 bulbs recently produced by the company had a mean lifetime of 1,475 hours with a standard deviation of 110 hours. Test the hypothesis that the mean lifetime of the bulbs has not changed using a 0.05, which is the 5% level of significance, the only one in the Leaving Cert course. And then find the p-value of the test you performed and explain what it means. Okay, so we're an autopilot here. It's a hypothesis test calculation. So there's our sketch. So sample group, where are they? Second line there, a second sentence, a sample of 100 bulbs. So n is 100. So step 1, find your value for n. Step 2, pick your symbols. P hat and P or X bar and mu. What was the question we asked here? How long was the bulb's lifetime? So that's numerical data. So it's mu and X bar. Okay. Step 3, grab the results from your sample group. So for the sample of 100 bulbs, the mean was 1,475, and the standard deviation sigma was 110. And then finally, step 4, because we're doing a hypothesis test, there should be a number I haven't used yet that goes up here for me to compare the results of my sample group to, and there is in the very first line, the 1,500. And now, yet again, I'm done with the text. I don't need to revisit the text now. I've got all the information I need. So we'll do our hypothesis test now. So starting off, H0, remember, as always, is this guy here. So mu equals 1,500, and I'll put the units in just to be safe. And then HA is that mu is not 1,500 hours. Now, do a calculation. Pick your favorite calculation. You could do the 95% confidence interval. You could find the Z statistic, or you could find the p-value. Now, if I'm reading the question in the exam, okay, I know that the p-value is coming up. Wouldn't it make sense maybe to use the Z statistic here because it's the first step in doing part 2 anyway? Of course I can find the 95% confidence interval and get the right answer. That's fine. I'm going to find the Z statistic because I know that's the first step now in doing part 2 in a moment. Okay? So if I get my Z statistic, remember it's X bar minus mu, so it's 1,475 minus 1,500 all over sigma, which is 110, over the square root of 100. And that Z statistic comes out as minus 2.27. Right? So you can see that that's not between plus and minus 1.96. So I'm now absolutely certain if I did find my 95% confidence interval, that number is not inside it. And actually, if you find the confidence interval, it comes out as 1453.4 to 1496.6. So yeah, that number is not inside the interval, which is why this number here is not between plus and minus 1.96. And now I'll just draw my conclusion as usual. So Z equal to minus 2.27 is outside the range minus 1.96 to plus 1.96. So remember, because it's outside, you reject H0. Okay, and remember, rejecting H0 means your conclusion is there's a difference. So what does that mean here? There's a difference between the mean lifetime of bulbs now and what they were in the past. And what were we testing? Test hypothesis, the mean lifetime of the bulbs has not changed. That looks like garbage. It looks like it has changed. So there's no evidence the claim is true. Or there's evidence the claim is false. Anything along those lines. And that gets across the idea that the claim that it has changed, that it's still the same, looks like it's garbage. Okay, there's no evidence the claim is true. The claim is that the lifetime of the bulbs hasn't changed. Our conclusion is that it has, because our conclusion is there's a difference now. Okay, that's the idea. And then part 2, it says find the p-value. Right? So again, using that Z statistic now, we're kind of halfway there. Just take my normal distribution from page 36, 37, okay, with 0 in the middle there, and put that number in. So the number is minus 2.2, so about minus 2.27 down there, and plus 2.27 there, and find these two shaded bits here. So if you look up 2.27 in the formula booklet, I get 0.9884, right? Does that shaded area look like 9884? Nope, it's too small. Okay, that's less than half. That number is bigger than half. So 1 minus 0.9884 is 0.0116. So this bit here is 0.0116, which means so is that. And our p-value is just 2 times 0.0116, which is 0.0232. And again, unsurprisingly, that's below 0.05. So because the 1500 hours is outside the 95% confidence interval, our Z value of minus 2.27 is outside the range plus or minus 1.96, and our P value is below 0.05. The three things that would lead to rejecting H0. Okay? And explain what that means. Remember, the key idea to get across there, it means the probability of a different sample, whatever way you want to phrase it, just get the idea, probability that a different sample, so if I was to grab a different sample of 100 light bulbs, okay, having a mean further away from the 1500 that was the case in the past. So further away from 1500 than this sample is 0.032. If that 1500 hours was still accurate, this would be a very unusual sample group because there's only like a 2.3% chance we could find a group more unusual. Okay, so that would start casting some doubt on the initial supposition. So that's how we work with p-values and how we use them in hypothesis testing.